In this lesson, we'll be going over heat capacity and heat exchange. Jumping right into it, heat capacity is the amount of thermal energy required to change a system's temperature by 1 Kelvin or 1 degree Celsius. First of all, what is a Kelvin? Well, like Celsius and Fahrenheit, which are temperature scales, have very different scales. Like to go from Celsius to Fahrenheit, you have to multiply it by 1.8 and add 32, but for Kelvin it's not that complicated, as it has the same scale for each degree of temperature as Celsius. But what makes it different? To explain this, let's go back to the kinetic molecular theory. The theory that everything is made up of billions or even trillions of these little tiny particles called atoms. Depending on the temperature, these atoms can have more or less kinetic energy. In theory, an object can get infinitely hot, meaning it can have an infinite amount of kinetic energy. But let's think in the opposite direction. Can the atoms in an object get infinitely slower? Well, the answer is no, as the slowest that the atoms can be is not moving at all. This theoretical point is known as absolute zero, which is very different than 0 degrees Celsius, which is when water freezes into ice. Here, the particles do not stop moving, however they move slower in order to change the water from a liquid into a solid. On the Celsius scale, absolute zero is negative 273.15 degrees Celsius. However, in calculations, this negative can be a bother and it can make you end up with the wrong answer. To make it simpler, this point is 0 degrees Kelvin, making it impossible to have a negative in the equation. So in translation, 0 degrees Celsius would be 273.15 Kelvin. In questions involving heat, whenever we are given a heat in Celsius, we can convert it into Kelvin by simply just adding 273.15. Enough with the Kelvin scale, let's get back to heat capacity. Heat capacity is directly proportional to mass. So let's say that we have two ice cubes, one being 10 grams and the other being 100 grams. With the 100 gram ice cube being 10 times more massive than the 10 gram ice cube, its heat capacity is 10 times greater. However, when we look at specific heat capacity, which is the amount of thermal energy required to raise the temperature of 1 kilogram of a substance, we can see that these two ice cubes actually have equal specific heat capacity, because if we get a kilogram of each, it would require the exact amount of thermal energy to change the temperature. In terms of the formula for heat capacity, we measure it by how much heat is required to change the temperature. We call this the quantity of thermal energy, or the variable Q. Factors that affect this are the mass of the object, the specific heat capacity of the object, and the change in temperature of the object, which would be the final temperature minus the initial temperature. Let's try a practice question involving heat capacity. Calculate the final temperature in Celsius if 4.3 times 10 to the 4 joules of heat was added to a 21 kilogram piece of brass metal with a specific heat capacity of 3.8 times 10 to the 2 joules per kilogram Kelvin that had an initial temperature of 34 degrees Celsius. Right off the bat, we want to change this 34 degrees Celsius into Kelvin. And as we know, all we have to do is add 273.15, meaning that in Kelvin, this temperature is 307.15 Kelvin. Now remembering the formula, that quantity of thermal energy equals mass times specific heat capacity times change in temperature, let's input all of the numbers that we have. So 43,000 joules is equal to 21 kilograms times 380 joules per kilogram Kelvin. And then for the change in energy, if we remember that it's the final temperature minus the initial temperature, so we would put that as final temperature minus 307.15 Kelvin. Now what we have to do is multiply the mass by the specific heat capacity. Kilograms cancel out, and this gives us 7,980 joules per kilogram. Now we're going to divide it out on both sides. And now 5.39 Kelvin equals the final temperature minus 307.15 Kelvin, making our final temperature 312.15 Kelvin. And then to turn it back into Celsius, we are going to subtract 273.15 Kelvin, which will give us a final temperature in Celsius of 39 degrees. That's the first half of this lesson. But in addition to heat capacity, there's also heat exchange. While heat capacity talks about the amount of thermal energy to change the temperature of a system, heat exchange involves the exchange of heat between two objects of different temperatures. And so the formula is the mass of the first object multiplied by the specific heat capacity multiplied by the change in temperature equals negative of the mass of the second object multiplied by its heat capacity multiplied by its change in temperature. Here I have a very good question for heat exchange. Some hot water is added to 3 times its mass of some more water at 12 degrees Celsius, and the resulting temperature was 18 degrees Celsius. What is the temperature of the hot water? So the first step is always to convert any temperatures in Celsius that we have into Kelvin. So this would turn out to be 285.15 Kelvin for 12 degrees Celsius and 291.15 Kelvin for 18 degrees Celsius. Now remembering the formula, we can plug in the mass of the hot water, which is said to be 1/3 of the mass of the other water. So we'll call this one 1 kilogram, multiplied by its specific heat capacity, multiplied by the final temperature minus the initial temperature. So 291.15 Kelvin minus the initial temperature equals, remember, negative, and also the mass is 3 times more as the hot water, so we'll call that 3 kilograms multiplied by the specific heat capacity multiplied by the change in temperature, which would be 291.15 Kelvin minus 285.15 Kelvin. Now the reason why I just put the C variable instead of the specific heat capacity of water is because both waters have the same specific heat capacity, so we can simply cross them both out. Moving on, let's distribute the mass into the temperatures, and so this will give us 1 kilogram times negative of the initial temperature plus 291.15 kilograms Kelvin equals negative 873.45 kilograms Kelvin plus 855.45 kilogram Kelvin. And once we move this temperature over to the other side, we will get a resulting negative 309.15 kilograms Kelvin. And now to isolate for the initial temperature, we are going to divide out the kilogram from each side, leaving our answer in Kelvin. And also, since both sides are negative, we can just cross them out to make them both positive, meaning that our initial temperature is 309.15 Kelvin, but taking it one step further, we can turn this into Celsius by subtracting 273.15, and we get a final answer of 36 degrees Celsius. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing, as it shows me that you like what you see, which helps me post more videos. Anyways, that's all for now. I hope you have a wonderful day.